In this video, we will explore SQL Common Table Expressions, often referred to as CTEs. I'll explain how CTEs can be used to create temporary result sets, simplifying complex SQL queries and improving readability. So, what exactly are common table expressions? CTEs are temporary, named result sets that exist only during the execution of a query. These are named query blocks defined using the with clause. Because they are temporary, they exist only for the duration of the query. Using CTEs makes complex queries more readable by breaking them down into simpler logical blocks. Let's examine the basic syntax of a CTE. The structure of a CTE query begins with the keyword with, followed by the name you want to give to your CTE, represented here as CTE_name. Then, use the keyword as, followed by parentheses containing a select statement. Inside this select statement, you specify the columns you want to retrieve from your table using the from clause, indicating the table name, and the where clause where you define any conditions. After defining the CTE, you can use it in a main query, where you select from the CTE by referring to its name, CTE_name, and applying additional filtering using the where clause. CTEs begins with the with keyword, followed by the CTE name. The CTE is defined inside parentheses, using standard SQL. They can be referenced in the main query that follows the CTE definition. Be sure to use meaningful CTE names for better readability of your SQL code. Let's look at a simple example of how to use a CTE in SQL. First, a CTE is defined to filter high-value orders. The code starts with a comment, indicating the purpose of the CTE. Then the with keyword is used, followed by the CTE name, high-value orders, and the AS keyword. Inside the parentheses, a select statement retrieves order ID, customer ID, order date, and total amount from the orders table, filtering the results to include only orders where total amount is greater than 1,000. Following the CTE definition, the main query is written, starting with a comment indicating its purpose. A select statement retrieves order ID, customer name, order date, and total amount. The data is retrieved from the high-value orders CTE, aliased as H. A join operation combines the high-value orders CTE with the customers table, aliased as C, using the customer ID column. The results are ordered by total amount, in descending order. Here is a result set, showing columns for order ID, customer name, order date, and total amount. The data includes sample orders. For instance, order ID 10,428 is associated with ACME Corp., with an order date of May 14, 2023, and a total amount of $2,490. You can also combine multiple CTEs in a single query. The code starts with the with keyword. The first CTE, named North America Customers, selects customer ID, customer name, and country from the customers table, filtering for customers located in the United States of America, Canada, or Mexico. After a comma, the second CTE, named High-Value Orders, selects order ID, customer ID, and total amount from the orders table, filtering for orders where total amount is greater than 1,000. Following the CTE definitions, the main query selects customer name, country, the count of order ID as high-value order count, and the sum of total amount as total spend. The data is retrieved from the North America Customers CTE, aliased as N, and joined with the high-value orders CTE, aliased as H, on the customer ID column. The results are grouped by customer name and country, and ordered by total spend in descending order. In this diagram, the first CTE, North America Customers, outputs customer ID, customer name, and country. The second CTE, High-Value Orders, outputs order ID, customer ID, and total amount. These CTEs are then combined to produce the final result. Recursive CTEs are used to query hierarchical data, like organizational structures. The code begins with the keyword with recursive, indicating that the CTE will reference itself. The CTE is named Employee Hierarchy. The base case or anchor member selects Employee ID, name, Manager ID, sets the level to 0, and casts the name as the initial path. This selects the CEO since they have no manager. The union all combines the results of the anchor member with the recursive member. The recursive case selects Employee ID, name, Manager ID, increments the level by 1, and concatenates the current employee's name to the path. This is joined with the Employee Hierarchy CTE on the condition that the Manager ID matches the Employee ID. Finally, the query selects Employee ID, name, level, and path from the Employee Hierarchy CTE and orders the results by path. Here's how recursive CTEs work. The recursive keyword indicates that the CTE will reference itself. The anchor member is the initial query that starts the recursion, located above the union all. The recursive member references the CTE itself, located below the union all. Termination occurs when no new rows are returned. You must include termination logic to avoid infinite recursion. These are commonly used for hierarchical data, series generation, and pathfinding. Let's explore the benefits and use cases of CTEs. Key benefits of CTEs include improved readability, allowing you to break complex queries into logical, named components. They also promote reusability, because you can define a result set once and reference it multiple times within the same query. CTEs can enhance performance, since the SQL engine can optimize CTE execution and may materialize results when appropriate. Finally, CTEs offer modularity, allowing you to isolate logic into smaller, testable units. Common use cases include data aggregation, where you can pre-aggregate data in a CTE before joining with other tables for complex analysis. They are useful for hierarchical data, through recursive CTEs for organizational charts and more. You can use CTEs for multi-step calculations, performing sequential transformations on data through multiple CTEs in a single query. They are also helpful for complex filtering, where you can create a filtered dataset in a CTE, and then apply additional logic in the main query. Here are some best practices to keep in mind when working with CTEs. Use meaningful names that describe what the CTE does or contains. Keep CTE queries focused on a single logical operation. Use comments to explain complex logic within CTEs. Consider performance implications for large data sets. Test recursive CTEs with small data sets first. Avoid overly complex CTEs that are hard to understand. Be cautious with recursive CTEs to prevent infinite loops. In summary, common table expressions, or CTEs, provide a powerful way to structure complex SQL queries into manageable, readable components. They act as temporary result sets that exist only during query execution, allowing you to reference them multiple times. CTEs improve code readability and maintainability. Multiple CTEs can break down complex problems. Recursive CTEs handle hierarchical and graph data. CTEs are widely supported across major SQL databases. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.